Hey everyone, it's Nick. Welcome back to another duality repair video. Today I have a Tektronix 2205 20 MHz dual channel oscilloscope. Just got this in from eBay. I bought it for the very reasonable price of $30. I believe the issue was it's got some issues with the vertical deflection. So let's power it up. I have not powered it up. This will be the first time. It's plugged in. Let's power it on and see what's going on with this thing. We have a beam. It's obviously good. And yeah. Sure you can see that. Yeah. There you go. So, with no input, we have some noise on the vertical deflection, so that's what they're talking about. I've never worked with one of these Tektronix 2205, so bear with me as I figure out where all the buttons and knobs are. Not crazy about the focus. So this is channel 1. Let's see what channel 2 produces. Let's go to the same volts per division. Right now I'm at 1. It's got it too. So if we go to both, yeah, they have the same thing. So obviously there's not a problem with a single channel, but something that's common to both channels. So that's what we're going to have to figure out. Let me change the horizontal here. Keeps in line pretty well. You can see it all the way up. Curious what it will look like if I have something hooked up. So I hook it up to the cal signal maybe. I'm gonna go back to channel 1. Let's go to channel 1 and where is it? Just put a probe in there and hook it up to the cal signal and see what we get. Curious. You can see, so that was the ground. DC and AC both look like garbage. I doubt I'm going to see anything on this. Let's take a look. Yeah, it doesn't look good. DC, nothing. It just looks bad. Doesn't look good. Try channel 2 quick. Change the volts to per division. There we go. Not much going on there. See that change a little bit. Well, it's just adding it to that noise. Very ugly though. Obviously some noise going on. We'll have to pull up the service manual, take a look at what could possibly be causing this. First guess would be capacitor or capacitor related issue on the vertical deflection circuit, or maybe the power supply. Could be the power supply itself with some noise. Not sure yet, so let's pull up the schematics and take a look. Before we start digging into the schematics and looking at the vertical amplification circuit, I pulled this up from the service manual. It's got the power supply test measurements here, so you can see this little table here on the right, and it's got 6 voltages to measure: negative 8.6, positive 5, positive 8.6, positive 102, positive 205, and positive 22 unregulated. 5 of these 6 are on the main board, and I pulled their locations up here from the service manual. And of course, this is a scanned copy. That's what was available online, so it's very difficult to read everything, make it legible at all. So I wrote down each position. So you can see the positions here. They pretty much line up. W989, 991, 987, 984, 985 are all on this main board here. And they're all kind of right next to each other, right in the middle here. So I should be able to find those pretty easily. This 6th one, 22 unregulated, we find on the time base attenuator board. And that's right at the top. So that should be fairly easy to find, depending on where these boards are located. So we'll go after these first. We will make sure that they are within specifications, and then we'll see if there's any ripple on any of these. Specifically, I believe the vertical board uses negative and positive 8.6 and the positive 5. So these 3 we want to pay particular attention to. Might as well check the other 3 as well, because they're all critical. So I will get this thing open and we'll take a look at these voltages. Alright, I was able to remove the unit from the case, and I have it flipped over on its side, exposing the main board. And so let's just go through these test points one by one. Starting with 989, this should be negative 8.6 volts. And we'll check DC first. So 989's up here. Looks pretty good, negative 8.6. Let's do 991, which should be positive 5. 991 is here. 5.06, good. 987 should be positive 8.6. 987's here. Looks pretty close, 8.7. Spec for that is to 8.86, so that's good. Okay, let's go to 984, which is 102 volts, so I'll need to change my scale here. 984. 102.9, 103 volts. The spec is plus or minus 3 volts, so that one's good. 985 should be plus 205 volts. Here. Oops, gotta change scales again. 985, 210, 211. That's the upper end of its spec. Upper end is 211.1, so we may want to adjust that one. It's probably for a CRT voltage there. And that final voltage is on the attenuator board, so we'll have to look at that one later. That one's unregulated anyway, and I don't believe this has any effect on the vertical, so I may skip that for now. But let's go back and check AC on all these test points. That's really what we're curious about, right? So let's check AC, starting with W989, the negative 8.6 points. So 989, checking for AC, nada. Good. 991, positive 5 volts, very critical. Nothing. 987 should be plus 8.6. Check AC on that one. Nothing. And then we'll check 102, point 984, which is 102. Might be a little bit on that. Nope, nothing. And 985 here. Practically nothing. Okay. I think it's safe to say that we don't have a power supply problem, as in a filtering problem, causing ripple to traverse its outputs, specifically the vertical board. So Now we'll have to dig into the vertical amplification circuit and take a look, see where we want to poke around there. So I'll be back when I have that circuit printed out. Here's the schematic for the vertical amplification circuit. I understand it's pretty difficult to read. Not only it's very small, but it's, as I said, it was scanned. It's a scanned version, so it's almost illegible. But we can get the general gist of what we're looking at here. So if you look at the top here, this is the channel 1 input and the preamplifier. The bottom is channel 2's input and preamplifier, and then in the middle you have your channel selector switch. I'm not really concerned with these areas since we have noise on both channels. There's hardly any commonality between them here at all. Where I'm going to start, where I'm going to focus is in this middle section here, which is the output amplifier driver circuit. And really there's not much common between them there either, but there's a little bit. So I have a zoomed in picture of this right here that we can look at. So we have our signals from channel 1 coming in here on the left and the top, and channel 2 on the bottom. Each obviously is fed into a transistor, Q203, Q202, and then they go their separate ways. Channel 1 up through this transistor and out, channel 2 down through this transistor and out. But where do they have commonality? Right here in the middle. So they have this resistor R204, this resistor R215, and this capacitor C215, I believe, maybe 16. So these are items of concern, specifically that capacitor. All right, anything that is common between the two channels is of concern. Where I'm going to test first is on these test points. So there's a test point here, and they're actually shared, W224 and W225. I was able to find W224, so I'll check there first. So let's take a look at that point. And that's going to be right there on the board. You can see W224 right here, which is going to be right there. So I'm going to power the unit up. It's not plugged in yet. I'm going to power it up, and I'll show you what really matters is the scope, my other scope. I'll power it up now, and we'll see if we get any noise on that test point. If so, well, we can rule out portions of the circuit based on what we find. The unit's powered on. I'm going to give it a second, make sure we have a beam. Yep, I have noise on that beam. So let me probe that test point. Look at that. Noise. Looks identical to what we have. Maybe not identical, but that's nasty looking. Right? Yep. Okay. That means we don't really have to go any further into the amplification circuit. We have to go backwards. And I said specifically that capacitor was of concern because that's common between the two. I might check there first, so let me show you that again. So again, this is the output amplifier driver circuit, right? So here's the main circuit for the entire circuit, right? I'm looking here at the output amplifier driver, and I'm testing here, and I'm getting noise. So that means I don't have to worry about looking post this test point. It's not happening. We're not getting noise introduced in the vertical output amplification circuit. We're getting noise introduced probably here or maybe somewhere back. But I'm going to focus still on the output amplification driver circuit, which is again here. Again, I'm testing here. I have noise on these points, so we have to work backwards. So right now I'm going to try and find this capacitor. It's 215 or 216, difficult to tell. And I'm going to test on either point on either end of that capacitor and see if this capacitor is what's causing our issue. So let me try and find that. Alright, I was able to locate C215, so I'm going to start probing, see if I get a signal on either side here. Nothing on that side. Some strange noise on that side. So I'm back on the test point just to get it locked in here. There we go. Now I'll go back to C215. Okay. So this is my input on one side. And that's what I get from the other side of that. It's nasty. You go to the resistor that's in line with that. Doesn't look good either. So no, it doesn't look identical to this. When you have an input like this to the capacitor and an output like that, I'm going to say that capacitor is faulty. So I'll flip the unit over. We'll take a look at it. See if it physically looks in bad condition or not. Regardless, I'll likely want to replace that and see if that makes a difference. Pulled the capacitor out, and I'm definitely second guessing myself at this point. The capacitor is ceramic. It's not an electrolytic. I don't think that thing failed. So I went back to the schematic, and again here's the capacitor in question. Again, no noise on this side, and then the noise is introduced on this side of it. So I assume this capacitor was bad. But I noticed that our negative 8.6 voltage input is coming in right here. So now I'm thinking about the power supply again. So what I'm going to do, and I know I did it earlier, is I'm going to check those test points again. I used the multimeter on the AC mode. That's not necessarily going to pick up the noise. So I'm going to try it with the scope. So I have the scope hooked up there. I'm going to power the unit on. So let's take a look. So let me run through the test points again. And of course I've got to find the sheet of test points on it. There we are. I'm going to start at the negative 8.6. Again, this is what we're looking at here. Right here. Negative 8.6 is test point 989. So let me check that test point, 989 right here. Huh. So look at that. Good deal of noise there. Obviously, it's not regulated very well. Let me check the other one. Plus 5 volts, 991. Let's check that one out. Plus 5 has a very similar thing. So this should be a straight line, obviously, if it's filtered properly coming into the unit. So let me trace back a bit. I can see the traces on the board, so I'm going to look at the negative 8.6 rail and go back to, let's see, so this is negative 8.6, this is the inductor that's in line with it. We still have noise here, a lot of noise on that end of the inductor. The inductor actually pulls out a lot of the noise. And let's see where we at. 989. And then here's the capacitor in line with that. There it is. Okay, so this is again the test point for negative 8.6. Let me go to the capacitor that's in line with that. So that's one leg of the capacitor, and that's the other leg. So we're just not filtering, and it makes more sense because these are electrolytics. Power this off. So most of this main board contains ceramic capacitors. Power supply, however, power supply section, which is still on the main board, contains several electrolytics. Let me show you here. So, clear. So here's the main board. You can see there's tons of capacitors, but a majority of them are ceramic, which aren't going to fail very often. Come over to the power supply section. So you see the main transformer there, the inverting transformer, and then you have your capacitors. These are electrolytics. These are subject to fail, especially if they're original. They've been in this unit for 30 plus years. So I think what's going to get rid of this noise is to replace all these electrolytics. Thankfully there's not a ton. There's probably 10 in there. And I think a lot of them are the same size and rating. So that shouldn't be too bad. So I know I don't have all of these spare, so I'm going to have to order some of these. I'll get some new ones in, we'll replace them, and we'll see if that makes a difference. I think it will. So I'm going to order these up, and I'll be back when I put them in. Old caps are out. New caps arrived. Let's install them. Good. There's one. 9 more to go. Alright, they're all in. I'm going to take a few minutes to make sure that I have them all in the correct orientation, because none of them are actually marked on the silk screen. Only one of them, where is it? Up here. That's the only one I can find with a marking on it. Up here, the positive. None of the rest have them for some reason. So the designation is the through-hole shape is either circular or square, and as you can hopefully maybe tell up here, the square is positive and the circle is negative. So I'll have to go around make sure it'll be easiest just to test from ground to each negative and make sure that they're all in the correct position, and then verify I have the correct polarity on the capacitors. If those all look good, I will clean the bottom of the board up and we'll power it on. See what we get. I verified the correct polarity of the caps. I cleaned them up a little bit, cleaned the board up a little bit, I should say, and I have the scope plugged in. I'm ready to turn it on. Let's see if we have any magic smoke. Certainly hope not. Alright, it's on. So let's take a look at that test point with my scope. It was W989 up in your upper right corner there, the negative 8.6 volts. That's the one that's directly tied into the vertical circuit. So let's probe that and see what we get. Hopefully we don't get that noise that we got before. Now obviously I could just look at the screen on the scope and see if the noise is there. I want to check this out first. Hey, that looks pretty good. So I'm on test point W989, and rewind just a little bit to get a refresher on what that noise used to look like. And I'm checking both sides of that cap 989, which is filtering the negative 8.6 volts, and it looks good. Let me check some of the other test points. They also had some noise on them. This is the plus 5.2 volts. Let me get it on there. A little bit. Oh, that didn't sound good. That didn't sound good. Something just popped there. I'm going to power that down. Yep, something just popped. Oh boy. Well, let's I'm going to unplug it and turn it around and take a look. Bummer. So the two caps in the middle there, you can see the one on the right pretty clearly. Right here, it's bulged, that one blue. And then the one just to the left of that, blue as well. The other 8 look to be in good shape. So this is directly, both of them are directly attached to the two out points I was testing, so I may have inadvertently shorted something. So I'm going to replace those again. We'll power it up, and we'll see if everything's okay. If not, I'll probably have to dig a little bit deeper. I did verify the orientation is correct, the polarity, as well as the cap sizes and ratings themselves are correct. So I'll replace those. I bought a few extra spares, and we'll see if that works any better. Alright, I removed the two caps, and I blew these things to smithereens. You can see the one on the left is a little bit worse, but they're both blown. That's after being installed and powered on for maybe 30 seconds. So you can see the one on the left started leaking out of the bottom too, or maybe it ran down the side. But this one just blew really bad, and this one as well. The other ones look fine, and I'm pretty confident that these are the only two that are going to be at fault, and I'll show you why. I found out what went wrong. So this is a clip of the power supply circuit, and this is and I understand that the resolution on this drawing is terrible, but again, this was a scanned copy, so I have to work with what I have. So this is the positive 8.6 and the negative 8.6 rails, and so I made a mistake. 100% my fault. These two capacitors are these two capacitors, and if you look at the orientation, the positive is to ground in both cases. And that makes sense because this is the negative rail. So that was a complete oversight on my part. 100% my fault. I wasn't thinking about that negative rail when I was installing the caps. I just wanted to get them installed, and I tested each pin of the through holes for the negative, and I put the negative leads of the capacitors in each. But these two I obviously needed to switch around. So I removed these. I installed 2 new ones with the correct orientation, with positive to ground and the negative to the negative 8.6 rail. I just hope I didn't damage anything permanently on the board or any other components. It's possible that I did. We'll find out. So, you know, part of being an electronics technician is making mistakes. But to become a good, successful electronic repair technician, you have to acknowledge and learn from your mistakes. So, I assure you I haven't made that mistake before, and I will not make it again. So let's move forward with the testing. I'm going to do the exact same thing I did before. I'll power it up. We'll check for noise. And I'll leave it on for a few minutes to see if I hear any sizzling. I sure hope I don't. Again, I may have fried something else. We'll see. I hope not. So here goes nothing. I'm going to power it on right now. No immediate smoke. So let's take a look at these 2 caps. Let's start with 989. Alright, there's very minimal noise on there. Little bit. That may be expected, especially compared to where we were at before. And then I'll check the other cap. There's a bit of noise on there. A little concerned about that. Let's check the actual test point, W989, which is the negative 8.6. A little bit of noise. Little bit. We definitely had a lot worse noise before. Change the yeah, no, it doesn't look like it did before, so we'll see. Check a few other test points. This is the positive 5.2. That's the same. So that may be a standard amount of noise. I'm gonna leave this powered on for a few minutes and make sure I don't hear anything sizzle. And if not, we'll be back to look at the signals and see if that noise is gone or if we have more work to do. Here's a 10 kilohertz signal going into both channels. Looking pretty good. Again, a little touchy on the triggering, so that I might need to look at that a little bit. But that could be a source issue. I don't have a generator at this moment. Let's cut that. So I have a 10 kilohertz sine wave going into both channels, and it's looking pretty good. The triggering looks a little shaky, but I mean, you can see the sine wave pretty stable there on both channels. They overlap very well, so I would say there's no adjustment needed as far as any amplitude adjustment. The gain on either channel looks pretty proportional, pretty equal to each other, so that's good. I don't think I can go any higher as far as any higher of a frequency, because I don't have a signal generator at the moment. What I'm using right now is a 10 kilohertz tone file from YouTube via my laptop. I'm plugging in a simple audio cable to the headphone jack, and then disconnected them. Using the probes to connect up to those, and that's what's giving me my signal. If I go too much higher, I think the capabilities, limitations of the computer itself show that it's just a lot of noise on here. And this is a 20 megahertz scope. I highly doubt that the scope can't handle 50 kilohertz. I think it's more my the source. So I'm gonna call this one looking pretty darn good right now. We obviously got rid of the noise with the caps, and each signal is pulling up each channel is pulling up a trace very well. Everything seems to be working pretty well. Intensity dims out, and maxes out. Focus is adjustable. Yep, you can see that clearly out of focus there and there. I'll have to play around with a few others. The volts per division, obviously working. Triggering's tough to trigger there. Gotta get it in the right. There we go. And our time scale knob is working. Horizontal position, I guess I haven't checked that yet. That looks pretty good. I checked both vertical positions. I am in auto trigger. I can put it in the norm, and that lets me manually trigger, and I should be able to, should be able to trigger. Obviously, I prefer auto. Can change the slope, so you'll see the trigger changes based on the rise versus the fall of the slope, so that's working. Everything seems to be working pretty well on this. I'm going to call this scope, this 2205 20 megahertz Tektronix scope, fixed, and I'm going to get it cleaned up. I might clean up these dials, verify everything's working again, and then clean it all up externally, get it back in its case, and then make room on the bench for the next scope. I have a 2213 I just got in, so I'm ready to work on that as soon as I can. So we'll see you on the next one. Thanks for watching.